This problem says a Playground merry-go-round has a mass of 120 kg and a radius of 1.8 meters, and it is rotating with an angular velocity of 0.5 revolutions per second. What is the angular velocity after a 22 kg child gets onto it by grabbing its outer edge? The child is initially at rest. Okay, so here's a here's a top view, and here's a merry-go-round that is, so the mass of the merry-go-round is 120 kgs. Its radius is 1.8 meters. We'll assume the merry-go-round is a disk, and okay, so here's the child who's at rest. When the child jumps on to the merry-go-round, what is conserved is angular momentum before he jumps is equal to angular momentum after he jumps, and that's moment of inertia of the merry-go-round before he jumps times, so this is the moment of inertia of the merry-go-round plus the boy, and so final angular velocity. Now in this problem, this increases, so that has to decrease. Okay, so the final angular velocity will be less than the initial angular velocity. So final angular velocity is I initial or I final times omega initial. Okay, so let's calculate all these quantities. So I initial is, okay, now the merry-go-round is considered to be a uniform disk. It's not stated properly, but well, so mr squared. That's the moment of inertia of a uniform disk, which is, so this is 120 kg and 1.8 meters squared, and this is equal to 194.4 kg meters squared. The final moment of inertia is the moment of inertia of the disk plus the moment of inertia of the boy, which is the boy jumps onto the edge, so it's that mass times r squared, his mass times r squared. Okay, so and that works out too. So the final moment of inertia is the moment of inertia of the disk, which is 194.4 plus the mass of the kid is 22 kgs, and he at the distance of 1.8 meters from the axis of rotation. .3. So you can see that the kid, when he jumps on, he changes the moment of inertia substantially. Okay, at least by 50%. Well, roughly by 35%. Okay. So omega final is I initial over I final times omega initial. Alright, so I initial is 194.4 kg meter squared, 265.7 kg meter squared, and the initial angular velocity is half a revolution per second. Alright, so this works out to okay, so 0.37 revolutions per second. So that's the final angular velocity. Alright, let's finish this problem.